Thank you, everybody, for coming out. I'm really excited to be here and talk about a project that I've been thinking about and working on for the last year or so, and going to be focusing more on in the next year. And it's a way to build user interfaces in the web browser using just Python. So no JavaScript, no HTML, and no CSS. If you're familiar with Plotly or Bouquet or other libraries, Jupyter widgets, we've already been doing a lot of work in this. But Dash is a way to make more fully featured applications in the web browser with just Python. So we've been doing work in making interactive visualizations in the web browser with just Python by abstracting away the D3 and WebGL that you might need. But when it comes to creating more sophisticated applications that involve more types of controls and more interaction between those different controls, we're still not quite there yet. We saw a lot of really great talks about custom data visualization interfaces yesterday, and a lot of those inside those companies required a full team of front-end and back-end and data scientists, engineers to execute. The type of applications that I'm talking about are things that look like this. This is National Instruments' LabVIEW controller. There's all these different controls in here. These types of interfaces run like physics experiments. We've got sliders and dropdowns, multiple graphs. We're still not quite there yet in order to easily make these types of interfaces using just Python. If you're working in something like Mathematica, if you're familiar with it or you've done it in the past, there's some abstractions in that platform that allow you to make really nice widgets and applications. And these look something like this. And lots of different sliders, controls, checkboxes, but they exist just in the Mathematica notebook. They're not really portable unless you have a Mathematica license. And aesthetically, they're really challenging to customize. An application like this wouldn't be something that you would publish, say, on the New York Times website. If you're working in MATLAB, or if you've worked in MATLAB in the past, you can make these really cool interactive applications using this program called Guide. These applications look like this. There's these different controls. They update live. But again, you have to have a MATLAB license to be able to use these, and they're not really portable because of that. They don't really work across different platforms. You definitely couldn't view this on your mobile device. And aesthetically, it's probably pretty hard to change that light gray background. This is another example of a MATLAB interface that I really want to be able to make in something like Python and not have to use anything else and be able to share it really easily. And these can get pretty complicated. Lots of different controls, lots of different graphs. Now, if you're working in R, you're in luck. You have Shiny. This is an example of a Shiny application that is written with Plotly's R library. And we've got sliders, graphs update each other's graphs. There's multiple controls, and all of the components relate to each other really nicely. And the cool thing about this is that you're just writing R code. You're not writing JavaScript or HTML or CSS. All you're working with is R and the actual data and simulations that you're working with. Here's another example of a Plotly R Shiny application. Different graphs can update the other graphs. You can do custom filtering, do custom interactions between all of the different elements in the app. And then if you're a JavaScript programmer, you're also in luck. There's a lot of really nice frameworks out there like react.js that make building these types of applications really easy. And with plotly.js, we've abstracted away a lot of the really hard things around WebGL, D3.js, animations, that make it really easy to build these applications. But you have to be working in JavaScript, and the scientific and data analysis tools inside that language aren't quite there yet. They're not at the place that Python or R are. Here's another example that I like a lot from the New York Times. This is also written in JavaScript. Really cool interactive applications that you can build if you're a JavaScript expert. And these are really cool because they're in the web browser, so they're really portable. Anybody can view them. Anybody can interact with them. But you have to be an expert in the JavaScript ecosystem. And usually that's not a prerequisite to being a data scientist, let alone like a biologist or a mechanical engineer. So I think to give you a good taste of what I'm talking about with Dash is just to do an example really quick. It's just about 40 lines, and we can recreate this really simple app here. So this is an app that, let's upload it, that will query Yahoo Finance. Oh man, the internet. I'm like the fifth person to say that. I really was hoping that I wouldn't be up here saying that. What this app would do is, as I would type in tickers here, nice, it's working now. As I type in tickers here, we're going to query Yahoo Finance to get data back, and then we're going to graph the result. So there's a few different components of this application. There's this header here, and then there's this text input. And then as I change values inside this text input, we're making an API call to Yahoo Finance, getting the data back. And then we're updating this plotly graph with that new data. And this is all inside the web browser. So there's a lot going on here. And I want to just try to recreate this. And hopefully we can all grok how Dash works. So Dash is a Python package. You just import it. You don't have to write any HTML, JavaScript, or CSS. You're working just in Python. We'll import Dash, initialize an application, and then we describe the layout of our app entirely declaratively. Dash comes with a series of components that include all of the basic HTML components like headers, H1s, H2s. If you're not familiar with HTML, those are just basic header elements, things like divs, tables, images. But it also comes with different higher level components, things like plotly graphs, text inputs, sliders. So let's just do a quick hello world example. We've got an app, and then we'll declaratively describe what we want our app to look like. So I'll just say my app.layout is equal to H1, hello PLOTCON. Save this. And here's our basic app. So we've got about 5 lines here, and we've created a really simple static web page. Now let's make this a little bit more interactive. Again, we're trying to recreate this example. So there's 3 components here. There's this header, there's this text input, and then there's this plotly graph. So let's add all of those components. We've got the header. There's a text input here. It looks like it's got a label called stock tickers, so label is equal to stock tickers. It's got a value here, which is set to Tesla. And then below this, we've got a plotly graph. If you're familiar with Plotly in our Python library, you also describe graphs completely declaratively. You set all of the attributes up front. So Plotly graphs are described by a figure. That includes data, which is like all of the different lines in the graph. And we'll just do a really simple chart here just to get something to show up. So this is the layout of our application. We've got this header up here. We've got this text input. And then we've got this plotly graph down here. So let's refresh. OK, cool. So now we've created this basic layout. We've got this header. We've got this text input. And now we've got this graph. That's just half of the app. So half of the app is the layout of it, what it looks like, the series of components that make up this app. But then the other half of the app is how these components relate to each other. So I can type into this text input, but nothing's going to happen yet because we haven't described all the functionality that we want when we type into this text input and then how the graph should update. In Dash, you also declaratively describe how one component should update another component. So let's just think about what we want to happen to make a graph that pulls some data from Yahoo Finance and then draws it as a line chart. It'd be some function like update graph. And as an input, we want to take the stock ticker. And then we want to query Yahoo Finance to get some data back. Luckily, Pandas makes this really easy. I think it's this. And Pandas has this data reader, which takes the stock ticker and then the back end to get the data. So this will just give us a data frame with this stock data. And then we want to update the graph with that result. So we describe our graphs completely declaratively, as we did above. We want our x data to be the date, so that's df.index. And we want the y data to be, say, the open price of that stock. And then we would return that figure. So intuitively, this is like what we want to happen. We want to just write a simple function that takes some inputs and then describes what we want the outputs to be. And to add this function to Dash, this is basically what you're going to be doing. Now, this is just a function out in the wild. It's not really tied to anything. To register this function as part of Dash, Dash comes with these decorators. So I'll wrap this function with a decorator that says, OK, which components should update each other? The first argument of this decorator is going to be the component that we want to update. In this case, we want to update the plotly graph. So I'll say the first argument is the ID of the component that I want to update. In this case, that's ID equals my graph. So I want to update my graph. And I want my graph to update whenever a value of this input changes. So this function is going to get called whenever this input value changes. That could be just one control, or in more complicated examples, there could be several inputs that update a single output component. So the ID of my text input is here, my input. And then Dash provides the whole component as an input argument to this function. So in some components, there could be several different properties that you'd want to access. If there's a double slider, you'd want both ends of that slider, and you want to get both of those values. In this case, it's just a simple text input. So to grab the actual text that's in that text input, I set stock ticker is equal to this component.value. And that value is set up here. So now let's just go over this again. We have this function that describes the data that we want to update and how we want to update our output component. And this decorator registers this callback function to my app, and it describes the relationship between these components. This function will take the input value of the text, grab data from Yahoo Finance, and just return the data as a figure as the output. And this will ended up getting updated and merged into the component on the left here. So let's save. Hope I didn't make any typos. cross our fingers and our toes. Nice. So now as I change this, I type in Coke here. Every time I input a letter inside this component, this function is getting called. So I type Coke here, and this function is now getting called with that value Coke, which creates a new data frame, puts the result of that data frame into this figure that we've described, and now updates this component. So hopefully we can all kind of grok this, but the main point of this is that we created this kind of cool dynamic app. It's pretty intuitive. We describe the output, we describe the layout of the app, what it looks like, and then what components should update other components. And it was all in about 40 lines of code, which is pretty cool. If you were to create this from the ground up right now, not using any of these types of abstractions, you'd have to write some JavaScript, some React, write your own server, some basic CSS to make it look okay. If you weren't using plotly.js, you'd be hacking away on D3. And the goal of Dash is to abstract all of this away, to allow you to declaratively describe user interfaces through a combination of HTML components, but also higher level components like graphs and inputs and sliders, and then allow you to describe the relationship between these components extremely easily, just by writing some simple Python functions. This is kind of a cool example because as I type in inputs here, a lot's actually going on. This app is making API calls to my Dash server. And then inside this function, we're making an API call to Yahoo Finance to get the data back, and then we're returning it. And this is happening every time I enter text into this text input. And it's pretty fast. So I think this wasn't really possible a few years ago because we didn't really have the web graphics to make it possible. And we didn't really have the abstractions in the front end to make writing these types of components like these text inputs and these graphs and other types of controls that we'd want. Those weren't really available to us a few years ago. So we can expand this example to be a little bit more complicated and include things like a table. So now this function, this text input is updating two components. As I type in data into the text input, we're updating the table, but also the graph. We have all types of components available to us, not just text inputs, but also dropdowns and tables. With Plotly and plotly.js, we've got really rich maps that are available to us that we can immediately access in our application. As I select different values inside this dropdown, my graph can update with that new data. Again, this app itself is only like 40 lines of code. We can use Dash to create just static pages, just things like reports in HTML really easily, where we've got really nice text, really nice CSS, but just text, a simple graph, published on the web, but you didn't have to really worry about the server, the HTML, the CSS. You're writing all this markup just in Python. Graphs can update other graphs. So in this example, as I click on points in this graph here, the other two graphs will update with line plots that show the slice through this contour plot. So it's not just drop-downs and sliders and text inputs that can be controls. Graphs can also be controls because the graphs that we're drawing in the web with plotly.js are totally interactive, and we get all of the events. All the events are accessible to us through Dash, like clicking and hovering and selecting regions. And with Dash, we can add custom callbacks to those interactions and update other components in any way that we want. Includes things like sliders, graphs updating other graphs. You can do your own types of brushing, all just with custom Python callbacks. All of this is possible because of a lot of different packages that are available. Behind the scenes, Dash is just running a Flask server. When I wrote my app.server.run down here, Server is just an instance of Flask. And this is really cool because it means that all of the rich plugins and functionality that we know and love from Flask are immediately available to us. We can make multi-page apps, add user authentication, and any other types of functionality that we'd want from a web server. Flask is written with a plugin architecture that makes it really easy to pull in different functionality from different plugins in the community. It's really, really lightweight. The other thing that makes Dash possible is React. If you're not familiar with React, react.js is a JavaScript framework for building user interfaces. It was developed and maintained by Facebook. And the core components of React are that we should be able to write really rich HTML and JavaScript widgets or controls or components that are completely standalone, that then we can distribute really easily. This includes things like date pickers, like sliders. And Dash components are built on top of React. And it's really easy to make your React component work inside the Dash ecosystem. The way that Dash components in JavaScript can be exported as Python components is all abstracted away for you. So you just have to write your React component with a few standard properties, and then we provide a way that you can export those properties as a Python package that then you can import. This ends up getting served by the Dash server inside the web browser, and all those properties are available to you. And then the other aspect of Dash in this web framework is really rich interactive graphs. At Plotly, we're developing one that we think is really great, and you guys should come over and check it out if you haven't already. But it includes all types of scientific graphs, 2D and 3D charts, on top of d3.js as well as WebGL. It's super performant. Because in the end, I really want to make an app that looks like this, but a little bit prettier and on the web. And that's going to require really high performance visualizations that really haven't been available until the last couple of years. And the other thing is, I think with Dash and React, we can start building more custom interfaces that become accessible to scientific programmers. So let me just pull up an example down here from one of my favorite authors on this topic, which is Brett Victor, where he thinks a lot about different user interfaces that we should be using to communicate our ideas more effectively. And I think the best medium for sharing our ideas and communicating our results is going to be in the web browser. But all of the real work that we're doing is in programming languages like R or Python or Julia or MATLAB, which don't easily make very portable results. So one of his examples that he shows in one of his essays is, how cool would it be if we could make these reports where we could slide the variables in our report and that would update other values. And so as I slide this value, maybe a new simulation is being run, and that's updating the other values inside this paragraph. And for this to be widespread, it has to work in the front end. But it has to be used by people that are doing the underlying research in the back end with languages like Python, R, MATLAB. And I hope that with Dash in combination with React, we can start making these new types of user interfaces and then distributing them to people that are doing the real science and the real data science work. So Dash is in pre-release right now. There's a prototype that you can check out, and we're going to be doing a more formal release in the new year that you'll be able to check out at this repo. If you're interested in this, please come over and talk. I'll be in this corner. And I'd love to hear your ideas and how you might use a framework like this and what you're missing from in the user interfaces that you're trying to build and share. Thanks so much. Questions?
Two quick ones.
Yeah.
Why Flask versus Apache, WSGI?
Just because it has a Python interface. So when you deploy these Dash apps, you're probably going to be putting it behind some application server to scale.
And then does Dash allow for collaborative parallelism? So
Mm-hmm.
users working on the same dashboard on separate pages?
It does. So one of the cool things about Dash is that all of this state of the application is in the web browser. And so the server itself is completely stateless. So that means that multiple people can open up the web page. All of the state and all of the variables are just in that web page, and we're just calling these functions with those new values. No state stored in the back end, so multiple people can access the same app at the same time.
Yeah, let's talk further than talking about potential collision of inputs and non-consumption.
Yeah, same thing. Yeah, exactly. Yeah.
Hi, just a quick question. So do I have to build the entire app inside Dash, or can I integrate Dash with other Flask applications or Django or any other
So
frameworks?
Dash itself is built off of a really standard set of APIs. So when you load the page itself, we make an API call that returns a JSON representation of the components that we're trying to build. And the JavaScript itself that renders those components is also standalone. So that means that you can build your own back-end interfaces to the Dash front end. So that could be an interface in some other server, like Django, or in some other language as well. All of the components are really modular.
So I just looked at Plotly a little bit, but I haven't really used it yet.
Yeah.
Can you help me understand what you showed using Plotly versus the Dash?
Yeah, sure. So Plotly itself is a JavaScript library with a Python interface and a platform that allows you to make any of these interactive graphs. And we have basic controls that you can also specify as part of the graphs. That includes dropdowns, sliders, play pause buttons, and animations. And we're going to be adding more controls to those graphs themselves. So to do that, you don't need Dash at all. You can just use Plotly through our web interface or through our Python library. But when you want to create apps that have data that's maybe unstructured, or data, as in my example, that's kind of unbounded, where you wouldn't want to upload all of the stock data into a graph itself because it just wouldn't load. And you have to, then that's a case where you might use Dash and tie your own Python functionality behind it. So for structured data, you're pretty well served already with our dropdowns and sliders in interactive graphs. Dash comes in when you need to deal with more complicated interactions. Yeah.
So on the GitHub repo for Dash, there's a message saying that there's an impending rewrite coming. I'm just curious what the current status of that is. It says it's
Yeah, so that's what I was showing off today, and that's going to be available in the new year. Well, I think that's it. Cool. Thanks so much.